All right, so now we're going to graph rational functions again. There's going to be a little bit of variation on this one. Um, Still going to go through the same steps. So again, first thing we want to do is we want to find holes. How do we find holes? We look for common factors in the numerator and denominator. So we're going to factor the numerator and denominator, and you're going to get a factored rational function that looks like this. Now, is there any commonalities in the numerator and denominator that would create a hole? In this case, there's none again, so we'd have no. Okay. We want to find the zeros. What makes the numerator 0? X equals 0. Set the numerator equal to 0 and solve. We now want to look at the y-intercept. Y-intercept is when x equals 0. So we substitute 0 in. We're going to get 0, and then 0, 0, and negative 2. So it'd be 0 divided by negative 2, which is 0. So y equals 0. We're going to look at the asymptotes. So we have vertical asymptotes. A vertical asymptote is where the denominator is 0. So we're going to have one at x equals negative 2. And we're going to have one at x equals 1. We're going to have horizontal or slant. So horizontal is when the degrees are the same or the denominator is larger. In this case, the denominator is 2. Here, the degree of the numerator is 1. The denominator has a larger degree. So this one's really easy to calculate. It's always going to be y equals 0 when the denominator has a larger degree. Slant, none. You can never have a slant and a horizontal at the same time. Then we're going to do other points if we need them. So let's take all this information and put it on the graph. We have a 0 at 0. We have a y-intercept at 0. We have a vertical asymptote at x equals negative 2. So we have x equals negative 2. We have x equals positive 1. Okay. We have a horizontal asymptote at y equals 0. So we have this. Okay. Do we have enough information to graph this? In this case, no. We don't have any idea what the graph's going to do. So we need to create additional points. So our equation is 3x over x squared plus x minus 2. Yep. Okay. So what are our additional points? We need additional points to the left of the left asymptote. So we need to pick out a point x equals negative 3. So I want to do a t-chart x equals negative 3. And I'm going to figure out what y is. So I'm going to take negative 3 and I'm going to plug it in. Over negative 3 squared plus negative 3 minus 2. That's going to become negative 9 over 3 squared is 9. 9 plus negative 3 is 6. 6 minus 2 would be 4. So it's going to become negative 9/4, which is negative 2 1/4. So then what I do is I come up here and I graph that. Negative 3, negative 2 1/4, which would be right here. Is that enough information to graph? In this case, yes. As it goes to the left, the graph's going to follow the asymptote out. As x goes to the right, it's going to be forced to go straight up or straight down, or look straight up and look straight down, but we can't go up because we can't cross through the x-axis because there's no 0. So it's got to be forced to go down. So there's that side of it. So now we need to know what it looks like in between the two asymptotes. So pick a number, negative 1. So I'm going to take negative 1 and I'm going to substitute it in. So then what that looks like is 3 times negative 1 over negative 1 squared plus negative 1 minus 2. So that's going to be negative 3 over 1 minus 1 minus 2, which would be negative 2, which is a positive 3 over 2, or 1.5. So then graph that. Negative 1, negative 1.5, which is right there, which means as the graph connects these two, the graph as it goes to the left is going to go up, and as the graph goes to the right, it's going to go down. How did I know it goes down? Because this multiplicity was 1. There's only one of those, which means it's going to go through the graph and continue to go down, whereas this here is going to continue and go up. Even though my graph touches that line right there, it shouldn't. It should just run along right next to it and look something like this and get really close to it, but not actually touch it. And then we want to do the right side. So now I'm going to pick a number to the right, pick 2, plug 2 in it. 3 times 2 over 2 squared plus 2 minus 2. So it's going to be 6 over 4. 6 over 4 would be 3 over 2. And so then we go up here, 2, maybe, 2, 3 over 2, which is 1/2. As it slides to the right, it's going to follow the asymptote out, and it's going to be going up because it can't cross through the x-axis. And that's what the graph looks like.